Hi everyone, I am Su Zhu-Yun and my partner is Liu Tianyi. We are from the final year project Group J from the FinTech programs of Class 2021. Our supervisor is Professor Yu, and the topic of our final year project is maximizing and visualizing the spread of influence on social media. Let's start with a brief background information to show the significance of our project. In the recent years, the number of individual social media users has increased rapidly. It is estimated in 2025 there will be approximately 4.4 billion individual users, which is 1.5 times of the number of users in 2017. With so much users on social media, enormous amounts of data traces are left behind. These data traces are often utilized for purposes such as targeted marketing and population health indicators. Therefore, providing straightforward insights is crucial in assisting marketers to make a more effective and efficient decisions. And the problem we want to solve is to reduce the difficulty in gaining intuitive insights regarding influence maximization on large-scale datasets. During our research, an effect worthy to mention is the word-of-mouth effect. The effect is about individuals showing positive experiences on social media with their close ones. See the rates this high as shown on the slide. A large percentage of marketers has put much more attention on marketing solutions such as influencer endorsements, and the results have shown to be effective. For our final year project, we have implemented a dashboard to generate multiple graphs on the influence spread of seed sets. The main features of our dashboards are first, letting users to choose their own seed set according to their preference. Second, comparing the expected and the stimulated marginal influence spread on each individual seed. Third, visualizing spread situations of marginal influence propagation depending on the seeds chosen. And last but not the least, display coordinates and centrality of individual seeds. And on the right hand of the slide, we have included a graph generated by our dashboard. And then in the next part of our presentation, we will perform a demonstration for our dashboard. This is our dashboard at the original phase without any inputs. The first step is to upload a dataset file, and we have only set the dashboard to recognize CSV or TXT files. If the file type is not the two that we mentioned, like here, if we upload a JSON file, it will show an error message like here. And now let's upload a TXT file. Because there is a processing time for the system to produce an initial graph, we have already uploaded a file, the same file here. And the processing time usually depends on the number of nodes. Here's the initial graph. From the dataset, once you hover a node, it will show you the information, like the number and the coordinates. And now, in the second step, the user can enter a desired seed site ranging from 1 to 50. A thing worthy to mention is that the function was originally set to process automatically whenever an integer is inputted, but we have changed the settings so the user will need to press enter or click a button stop on it to process. The setting was changed because we think that the user might accidentally modify a new integer and the system will have to rerun again, so we changed to save it for the time of the user. So for example, let's choose 10, and then we press enter. Here on the tab, you can see that the name has changed to updating. During the process, the tab will always change to updating until it finishes. It usually takes a few minutes to produce a single graph. So again, we have another tab open that has the second graph here. So in the first part of the second graph, produced, it is produced under in the LT model, and we can see the system indicating the seed set, like here. As you can see, there is a seed set of 10 nodes produced by the SIMPATH algorithm, and there is a bar chart that will show each node's expected and stimulated marginal spread. It is due to the threshold that is readily assigned to the nodes, so there will be a difference between the expected and the stimulated marginal inference spread. From step 3 to step 5, there are all independent functions. That means that if we press clear on either of the buttons, the graph will be deleted. Step 3, and again we have them already rendered to save time. And step 3 is that the user can choose a seed and see how the new selected seed will contribute to the influence spread. This is a graph that is produced by seed 3437. The 10 nodes that is listed here are listed according to their influence from the high to the low, and the left one is the highest. So you can see that 3437, how many nodes that it has impacted. And step 4 is that we can choose a seed set here and see the influence inside and outside the community. From the chart, we are able to see, like in step 3, the orange node is the node that we selected, and the purple nodes are the local activated nodes, and the dark gray nodes are the nodes outside the seed nodes community. Also, the edge color will revert according to the node application. We can explore the connection between the community structure and the selection of the nodes in the graph. And here, the last feature that we implemented is to show the centrality and the coreness of the node. The system will produce 4 plots indicating the coreness, the degree centrality, and the closeness centrality and the betweenness centrality of the node chosen. The lines in the plot represent a cumulative probability to show how many nodes that it suppresses. As we mentioned previously, in step 3 to step 5, they are all independent. So for example, if we press clear for step 3, then we'll turn to update. And as you can see here, the 2 graphs produced by step 2 has been in place of graph 3, while graph 4 and graph 5 still remains. So this is what we meant by the step 3 to step 5, they are all independent. And thank you for watching our video. This is the end of our demonstration. Thank you.